Hi students, welcome to Vision 2021 course batch 2. It's a trial course that you are seeing for today, and welcome to India's greatest online e-learning platform gradeup also. So okay, so I am saying first hi to all the guys who are on the YouTube and even on the app. Oh okay, coming to the today's session. Today's session is actually it is limit state of Flexure, which is used for the design of reinforced concrete structures, and using this limit state method of design for we are doing the designs, not the design exactly, the analysis for singly reinforced sections. Nandu AR, good evening sir. Good evening Nandu, hope you are doing good, right? Yes. So shall I start the session? Yes. Okay, so this is the session that you can see. Yes. Coming to the number of class, this is only one class for today. This is a trial class. Okay. Now you before I start the session, let me introduce myself. I am Tilak, completed my masters from University of Sheffield, England, and I am also completed some part of my PhD. I am about to complete my doctoral degree right now. I am also into research. In addition to this one, coming to my work experience, I already worked as head of the Department of Civil Engineering and also worked as a research scientist also. This is my brief background. Coming to my master's degree, I completed my master's degree completely from structural engineering background. Civil Tech, hi sir, hi, how are you? Yes. So this is my brief information. So let me start the session today. Lots of doubts. Okay, you can ask. Now, coming to the overview of this topic, Avinash Karmakar, what is the duration of Vision 21 batch second trial? I mean, you can expect like 10 days, 15 days like that. Avinash Karmakar. I hope I answered Avinash Karmakar also, right? Yes. Now, coming to overview of today's session. So, what I am going to teach you? I am going to teach you the analysis of singly reinforced section, right? I am going to teach you in limit state method. So I can write here analysis of singly reinforced section that I am going to teach. So what is this analysis of singly reinforced section using limit state method, LSM? Prakash says, please make some more videos sir. Yes, of course we will do. Please yes, we will do. Now in this one analysis, we will work out the actual depth of neutral axis. We will work out XU, actual depth of neutral axis, and I will also tell you the limiting depth of neutral axis also. I will tell you here how to work out, and moment of resistance of balanced section also I will teach you. Moment of resistance of balanced section I will teach you, and I will also teach you in this one about the limiting area of steel that is required for balanced section. So AST, limiting area of steel. This is because the time is only for 1 hour duration, so that I can cover this much extent, and in addition to this one I will cover problems over this. Okay, so that is the main agenda. You can see I am saying all these things based on limit state of method. Especially I will start this session by considering the limit state of method was taken basically from Euler's theory. So I will start with Euler's theory, Euler's Bernoulli's theory, and how the equation for stress block parameters, all that things also we will discuss. I mean stress block parameters also we will discuss. That means we will even derive that one with reason also. Okay, stress block parameters, and you can see definitely some changes in the questions as per whenever the permissible whenever the limiting strain in concrete has got changed, how the depth of neutral axis will change when compared to depth of neutral axis prescribed by IS 456 also. That also you will see. Now let me start our session. So coming to the first thing, as I already mentioned, we are going to deal with singly reinforced sections. Okay, now assumptions. Before we need to do any sort of analysis, we need to use some theory. So in that theory, definitely some assumptions will be definitely there. So what are the assumptions that we are using in this singly reinforced structure, in this singly reinforced limit state method of analysis? Yes, first one as made by Nandu AR, plane section remains plane even after bending. Definitely the first one is plane section remains plane even after bending. That means indirectly I can mention the same statement, there is no distortion in the shape of the cross section. That means there is no sort of warping will occur. That means if an element is straight before bending at a cross section, even after bending also there won't be any change in the shape. Okay, so that's what actually is the first assumption. Now people will ask us, what this means. So from this one, whenever there is no distortion in the shape of the cross section, you can understand the variation of strain in that particular section is a straight line variation. This is how actually is nothing but strain distribution, you can see. So this is how the strain distribution is linear in fashion, and the strain is zero at the level of neutral axis. This is neutral axis. And you should also understand this type of singly reinforced sections or doubly reinforced sections, all these are all composite sections, because it is composed of concrete and even steel. So it is not a homogeneous material, I can say. It is a, definitely I can mention this one is actually a composite material. So I need to use a theory in which that is useful to find out the depth of neutral axis and all this stuff for composite sections. So that type of analysis theory was, if it is a cube and it is subjected to some axial compression load on a cube, in such case, okay, generally the first crack in concrete will appear at a strain of, for any grade of concrete you take, the first crack will happen at a strain of 0.02, and the entire block, the maximum permissible strain in any traditional concrete you can take, except special concretes. For all traditional concretes like Portland cement concrete, any grade, okay, in such case it is 0.0035. So the maximum permissible strain is 0.0035, and the strain at the time of yielding of concrete, first crack is nothing but yielding of concrete, it is 0.002. So you can see, this has got this is one zone and this is another zone. This strain is the yield strain. This 0.002 is called yield strain, whereas 0.0035 is called ultimate strain in concrete, not in steel, man. For any grade of concrete, in ultimate strain in concrete. Now after this one, you can see, and I will also tell you in the next slide how the shape, here you can see the shape of this stress. This is how the strain distribution is. Coming to the stress distribution, here the stress distribution, you can see some block is a rectangular shape, some block is parabolic shape. There is also reason for that one in this coming one. So yes, 0.002 is also called as proof stress. Yes, of course. Now let me come down to the next slide. So the first one is plane stress, the variation of strain distribution is linear. That's what you can directly infer from this first statement. Sir, can we use limit state method in pre-stressed concrete? Yes, of course. First of all, let me define what is limit state method. Limit state is a state before which, just before reaching of that state, the structure is able to resist all the external loads, and it should also have satisfactory serviceability also. So before attaining that state, the element is able to resist all the external loads, and it should give satisfactory serviceability also. That's what actually is limit state means. Now coming to second assumption. So coming to second assumption, you can see, you had seen this is how, this is actually the stress strain curve of a concrete block. This is actually stress and this is actually strain. This is if you take the stress strain curve of a concrete block, generally for steel material, you can say from O to A, within the elastic zone you can see a straight line, but here you can see it's in elastic, within the elastic zone only you can see a parabolic shape. If you want, you can test over a cube. Definitely you can see a parabolic shape, and at this point A, where the first fracture will happen on the concrete block. So if you apply with the help of a load P at some load, first crack happens. Okay, that is this point. At the point at which first crack happens in the concrete, by that time we can say that concrete has got failed, right? Even after first crack, some crack has initiated. After some time, it will take even some more load, right? So at the point at which first crack has happened, we will consider it as FCK, and this is the actual failure point. But instead of this one, instead of this parabolic curve also, we are idealizing that. Okay, we are idealizing that. From O to A, it is a parabola. Instead of a parabola, after this first crack, we take it as a failure. From A to B, instead of a curve, we are actually considering it as a straight line. So this is the curve actually prescribed by IS 456. This is the actual stress strain curve of concrete. But what is the prescribed for curve in IS 456? This one. Why they had made it as a flat shape? In sense, we are already considering at point A it has got failed, and we are not interested in taking non-linear shape of account into picture after the failure. So that's the reason why they had considered from A to B as a flat curve instead of a parabolic curve. So I can mention this curve, this first curve is actually called, it is the stress strain curve of concrete specimens. I hope you can understand what is the difference between stress strain curve of structural concrete and concrete specimens. This is after this one, or in other words, this is also called as a characteristic stress strain curve for material. Okay, now after this one, characteristic stress strain material, this is for concrete specimens. Now if I want to get the stress strain curve for structural concrete, because if while you are testing concrete specimens, generally you will test over only either cube or at max a cylinder, but you are not considering the other shapes of structural elements. Some other shape of structural element can be in the form of prism. I mean, that means you are not considering the effect of shape and size into account for structural concrete. So this is the characteristic stress strain curve, whereas this curve, if you see, is the stress strain curve for structural concrete. So because in actual structure you take a beam cannot be a size of 150 by 150, right? Your column cannot always be a size of 150 by 150, definitely, right? So in this case, I can mention this curve is actually the stress strain curve for structural concrete. That means in the structural concrete, the stress strain curve, in the sense you had already considered the effect of shape and size. So for this curve, I can mention the word called considering the shape and size factor. Considering shape and size factor. Shape and size. So what is the shape and size factor that we had considered in IS 456? It is actually FCK, but how much is the stress that we are getting here? FCK by shape and size factor for structural concrete is 1.5 that we had considered in IS 456. So because of which you are getting it is 0.67. So I can write here shape and size factor for concrete is 1.5, but finally this cannot be directly, this stress strain curve cannot be directly used in design. In the design, whatever the stress strain curve that we are using, that must and should be the design stress strain curve. So let me show here. So what is this is called? This is nothing but design stress strain curve. Design stress strain curve, can I write it as sigma epsilon? Yes. Abhinash sir, after this please come over ultimate stress method. Dear Abhinash Karmakar, I am extremely sorry because the content here for this today is, it's already thing. Okay, yes, Prakash 1995 says, is there any benefit for considering flat shape? Yes, of course. When you consider this as a parabola, in such case the analysis will be complicated, but if you take as a flat one, the shape has become a rectangular, so that means complexity of analysis will get reduced, one thing. Okay, yes, let me tell you, I'm coming to Anandu here. Okay, now this is design stress strain curve. Why we had taken 0.45 FCK? It is equal to this 0.45 FCK. How I can get? I want design stress. So design stress for structural concrete, right? Design stress for structural concrete is the working stress for structural concrete. What is the working stress for structural concrete? It is FCK by 1.5, right? Divided by, and I need to consider even the partial safety factor for material concrete, right? So again divide by 1.5. So that's the reason why this is 0.446 FCK, or in other words it is 0.45 FCK. So what you could understand, the shape and size factor for concrete is 1.5, and one more thing also as a note I should write. What is the other thing? The factor of safety for concrete material in these assumptions of limit state method, as mentioned by Euler-Bernoulli's theory. From that only IS 456 has taken that one. So in that one also I need to consider 1.5. Now what is the overall factor of safety that you need to consider for concrete, that you had considered for concrete? People generally say overall factor of safety is 1.5. It is wrong. I just want to mention how. Okay, I hope you had taken this, but let me just use this. So what is the, now my question is overall factor of safety of concrete as prescribed by IS 456. Okay, not with respect to other codes. Okay, as per IS 456. What is the answer I am expecting from you? Can you tell me the correct answer? Prakash says 2.5. That is exactly correct. You can write it is 0.45 FCK is the design stress, right? So design stress, how you will get? Characteristic stress by, or characteristic strength by, let me write here overall factor of safety. Overall factor of safety. In this case, how you will get this overall factor of safety? It is a combination of 1.5 is the factor of it is the shape and size factor is 1.5, and one more factor is there, which is the factor of safety for concrete material itself. Totally together it is 2.25. So don't make any mistake. The overall factor of safety is 2.5, but the factor of safety for material concrete is 1.5. That is the difference. Okay. Now let me move to, so this is the curve that you can see in IS 456 stress block. Okay, that I am going to show you. Okay, now Amar Pandit, sir, why stress remains saturated? So here, actually here one crack has happened. This is what actually the thing that you need to consider, dear Amar Pandit. But from point A to point B, as already a first crack has happened, that time we will consider the strength of the concrete is FCK. So if you take this parabolic shape, that will increase the complexity of calculations of our analysis. That is the reason why we are making it as flat. Okay, actually it is a curve is there. Okay, for that one only we had considered that, right? Yes, yes, Amar Pandit, it is 0.002 to 0.035. Yes, it is 0.002 is the strain at first crack, which is nothing but this is strain at first crack, which is nothing but yield strain. 0.035 is the maximum strain that is possible in concrete under compression, which is 0.035 irrespective of any grade of concrete, except for special concretes. For any ordinary concrete or standard concrete, or if any high strength strength concrete also you take, that was made up of Portland cement. In any case, without addition of any polymers, the maximum strength that is allowed in it is 0.0035. Will it is depending on loading, sir? No, Amar Pandit, it is not at all depending on loading. So I mean it is for any grade of concrete you take, except for special concretes. For all the grades of concrete it is 0.0035 only. Okay, right. Ramdut Shah, what is factor of safety? Ramdut Shah, I can mention here for you the term called factor of safety. I had already mentioned here you. So the term factor of safety can be defined as the ratio between the term factor of safety, that we can define this as, it is the ratio between characteristic strength, you can write characteristic strength of that material to design stress of the material, or in other words it is characteristic strength of the material to design strength of the material. That ratio we will consider it as factor of safety. If we won't consider factor of safety, in such case, if there is a chance of material strength was if the material strength was overestimated, there is a chance of problem here. Civil tech, sir, why we need the overall factor of safety? As I already discussed, civil tech, if you take the test that we had done on concrete, is actually performing on a small block, but if you see the structure will have a size of this much and this much, which we are not accounting. That means the shape and size of the structure we are not accounting. So that's the reason why we are considering 1.5 is the factor of safety for shape and size, and 1.5 is the factor of safety for material. Total together 1.5 into 1.5 is 2.25. Okay, that is the answer for civil tech. Yes, you are correct. Yes, you are correct, Prakash. Yes, let me move to the next thing. And the code says like while we are working out this FCK, actually I need to work out on 30 samples, but 30 samples working out FCK using 30 samples is not possible. In such case, code IS456 mentioned like we randomly to express the compressive strength of cubes, which is nothing but FCK. In such case, I need to use at least 3 cubes, and the average at the rate of 28 days I need to consider, and the variation should not be more than 15%. Because if we are taking in random sampling, actually I need to consider 30 samples test. And as I already mentioned you, the strength of this concrete in structural members will be 33% less, because if FCK is the strength of the material, what is the strength of the same material in structural element? It is 0.67 times of FCK. So that means what is the drop in FCK? It is 33% after considering the effect of shape and size, right? That's what it means. And design compressive stress that you can already got, it is 0.45 FCK. I had already described how it is and why it is. And coming to the third assumption, is stress distribution curve is parabolic and rectangular as per Euler's-Bernoulli's theory. As you had already seen, you can see this is actually the stress strain curve for concrete. How it was there, you can see some part is under straight line, which is rectangular shape, right? Some part is under parabolic shape. So the stress strain curve for concrete under flexural compression, some parts of layers are under a stress block of rectangular shape, some part of the stress block are under parabolic shape. So that's what actually assumption 3 is, that you can that we can give reason from here directly. So the third assumption is that, as you already know. And coming to the fourth assumption, till now we had given the design stress for concrete, right? So what about the design stress for steel? So actually if you take any steel rod, so design stress for steel is 0.87. How you got this one? Design stress for steel, and it is equal to characteristic strength of steel material, which is Fi, by factor of safety for steel material, reinforcing steel material, which is 1.15. So I can mention 1.15 is the factor of safety of reinforcing steel. There is a lot of difference between reinforcing steel and structural steel, so please be careful. Okay, the factor of safety of reinforcing steel. Now coming to Sir, Amar Pandit says, sir, is it empirical that we can take 1 point, you have taken 1.5? Yes, of course it is empirical. After so many studies by so much experience, they had fixed to that 1.5 as the factor of safety. Okay, yes, because different code of practice will have conformed to different factor of safety values. Okay, yes, of course, yes, you people are correct. You are giving Prakash, Shravan, Kannikanti. Yes, you people are correct. Now, and in steel also, I just want to mention, for every steel, the design stress is Fi by 1.15, which is, you will get definitely as 0.87 Fi, no doubt. Now, how the steel stress strain curve was also considered in IS 456 as per Euler-Bernoulli's theory, because Euler-Bernoulli's theory is also applicable to composite structures until the structure has got failed, that is applicable. So, even Euler-Bernoulli's theory is also applicable to limit state method. That's the reason why they had just copied that and they had used it here. Now, this is the actual stress strain curve for mild steel. I hope you can understand. This is for mild steel. Okay. How this curve has taken, how this curve was idealized, how this curve was made in a simplified form in IS 456. This is the revised or idealized stress strain curve. You can see just this is the point, which is nothing but lower yield, right? So at this lower yield, you can see after this lower yield point, there is actually some plastic region is there. After some plastic region, there is you can see strain hardening zone and necking zone. We are neglecting strain hardening zone and necking zone, and after this yield one, we are neglecting strain hardening zone and necking zone. So the thing after this yield stress, which is lower yield point, I can consider it as only plastic zone is there. So there is no question of strain hardening zone is there, no question of necking zone is there, for our simplicity of calculation purpose. So if you consider even necking zone and strain hardening zone, it will be more complex in the analysis. But sir, Nandu here, sir, but in IS 456 we can take any shape for stress strain block na. So as long it is along these test results. Yes, of course it was also advocated, but every time you can't go and you can't take the same type of the things, right? So IS 456 advocated you can use this block. Of course you can use another shape also, which will have considered with the same area. To reduce our complexity, we are using the one and same called some part is parabola and some part is rectangular, which is already advocated or supported by Euler-Bernoulli's also. Okay. Now, here I just want to mention, yes, this is for the thing that I had shown in your earlier slide is actually for mild steel. Now let me show the stress strain curve for HYSD steel. This is the stress strain curve for HYSD steel. So here I had mentioned in your previous classes, not in previous classes, in the previous slide, the ultimate strain, or that means the maximum strain for concrete is 0.0035. Like that, people will also ask me like, sir, is the why there is no ultimate strain in steel was not given? Because I can mention, coming to steel, before steel generally concrete will fail first. So that's the reason why they had maintained a relationship. Generally the first crack in concrete will happen at the 0.002. So after 0.002, if you take this as an element, okay, after 0.002, first crack happened in tension zone. Then who is responsible to resist the actions in tension zone? After first crack has happened in tension zone of concrete, concrete cannot take any sort of tensile stresses. After first crack has happened, then from that time this steel material should resist this tension, right? So till by that time it has not started yielding. Now from 0.002, what is the strain that is possible in steel material? So for that one, there is we can generally mention the strain at that for steel is possible if you know the Fi corresponding to that yield stress, whatever may be the strain in that material, that is possible. But for HYSD bars, there is no upper yield and lower yield. Whenever there is upper yield and lower yield, in such case we are able to figure out what is the yield stress for material. But in case of HYSD materials or TMT rods, there is no upper yield and lower yield. So now how to to figure out that yield stress. If I am able to figure out the yield stress, then yield strain is already possible, right? So for that one, using this initial tangent modulus method, so we can draw a line which is parallel to this line OA, which is the proportionality limit. Draw a line, it will get intersect here. So this point, at this point, what is the stress that we are reading? It is nothing but yield stress. Okay, this is how you can consider. After yield stress, I already mentioned, we won't consider the necking zone, we won't consider even stress strain hardening zone. So that's the reason why after point B, we can consider it as a flat line. Okay, I hope you can understand. So this is the actual thing, but this is the idealized thing. And I want to mention this is a steel material, right? So which is a ductile one. So because of which from O to A it is a linear elastic, from A to B it is non-linear elastic. So that means from O to B the material is under elastic zone only. After B only it went into plastic zone, right? Prakash, I am coming to your one. Okay. Amar Pandit, sir, why not upper and lower yield? Why we are considering for HYSD? Amar Pandit, you are asking the question for yield stress in case of mild steel. For if there is upper yield and lower yield, we can consider only lower yield point, because the lower yield point will not change with respect to the grade of steel and with respect to the shape of steel rod over which you are investigating the stress. So that means upper yield point may change, which is shape and size sensitive, while we are working out the yield stress, but whereas the lower yield point is irrespective of shape and size sensitive. Okay, so that's the reason why we only rely on lower yield point. That is in case of mild steel, but in case of HYSD steel there is no upper yield and lower yield. So how to figure out the yield stress? So that's the reason why we are taking an offset method. So this point will be the yield stress. Now you can understand what is the strain that is possible. So this strain will be definitely the yield strain, right? Now how to figure out that yield strain? So this is the characteristic stress strain curve for HYSD steel rods. So let me write characteristic stress strain curve. But I should not, in the design I should not use a characteristic stress strain curve. Definitely I need to use design stress strain curve, right? Will you accept? So if I go for design stress strain curve, this is how the possibility is. So characteristic stress strain curve divided by factor of safety. So from this one, from this one it can go in this way. So what is this curve? Is nothing but the above one is characteristic stress strain curve, the below one is design stress strain curve. Design stress strain curve. I need to use this definitely. So what is this value of this stress here? It is actually design stress strain curve, means the characteristic stress by factor of safety. So you can easily understand this value is Fy by 1.15, which is 0.87 Fy. That is the thing that you will consider. Now corresponding to this design, this is actually design stress, right? Corresponding to this design stress, what is the strain? That is nothing but design strain. So what is the design strain in steel, right? Design strain in steel, or strain in steel at the time of yielding. Strain in steel at the time of yielding indirectly. So after considering factor of safety and everything, you already know to get this value, you already know this is how much? 0.002, right? So 0.002 plus this value, right? So how much is this one? You already know this is a tangent, this is a line that is drawn parallel to this one. So this slope is nothing but Young's modulus, right? Young's modulus of steel. And this vertical value, if you see, what is this vertical value? This vertical value is Fy by 1.15. So let me write Fy by 1.15. We generally call that 1.15 as factor of safety. Right now you tell me this extra value. So this horizontal distance is this value is Fy by 1.15 divided by Young's modulus of steel. Fy by 1.15 into 1 by Young's modulus of steel. So this is the design strain in steel. So how I got that one? Basically from this stress strain curve only. Okay, design stress strain curve. Sir, video lecture displaying not display. So if the video lecture is not displayed, please refresh that one, then you will get right. Okay. Yeah. Sir, Nandu says, sir, how we are able to transfer load into steel without brittle fracture in concrete exactly? In such case, without brittle fracture in concrete exactly, then you should make the steel should fail first rather than concrete. In such case, such type of failure is nothing but ductile failure, which is possible in case of sections called under reinforced sections. So if you provide less amount of steel than required amount, the steel will reach to permissible stresses prior. In such case, the steel will fail prior to concrete. In such case, such failure is ductile failure, which is possible practically in under reinforced section. This is the answer to Nandu AR. Okay, let me tell you. Let me move to the next one. So this is the minimum. Now, this is the minimum stress in steel that is required. If the stress in steel at the time of failure is less than this value, you can understand you are ensuring ductile failure. The stress in steel at the time of failure of any section should be more than this. Then only you can understand it has reached the permissible stress. Whenever the steel has reached its permissible stress, it has got failed. So that is a good thing. We are here to make steel to fail, not the concrete to fail. Okay, so this is the minimum. This is the strain in steel that needs to be minimum at the time of failure. Okay, so that's the reason why I had mentioned here greater than or equal to. So if the strain, let us suppose, as you had already seen, if the strain in steel is less than 0.002, in such case, if epsilon st, strain in steel is less than 0.002, in such case, which one is failing? In this case, concrete is failing. Concrete is failing means the failure is a brittle failure. Brittle failure, and it is a danger thing, brittle failure. So brittle failure should not happen. Okay, so always to ensure ductile failure, this this final thing, this minimum, this is the minimum strain in steel at the time of failure. This should happen. Okay. Now I am moving to stress block parameters now. So coming to the stress block parameters, what are in the stress block parameters? What can I teach you? I can teach you about the depth of neutral axis. I can teach you about limiting depth of neutral axis. I can teach you about moment of resistance for a balanced section, MR, limiting moment of resistance. I can teach you, or moment of resistance also I can teach you for the section. This is what we are working out as per IS 456. Okay, as per IS 456. Prakash 1995, what about my question, sir? What you mentioned, sir, how much strain consider for mild steel in design? So for dear Prakash, how much strain you need to consider for mild steel? The same thing that you had seen, which is 0.002, you need to consider. Now coming to Shravan Kanti, under reinforced is better. Then yes, of course, your answer is correct, Shravan. Under reinforced is always better, definitely. Now this is how the stress block is. If it is the stress block, if B is the width of the section and D is the effective depth of the section, in such case, this 0.0935 is the maximum strain and this is the yield strain. Let us suppose the depth of this, depth of this parabolic portion is x1, and let us suppose the depth of this rectangular portion is x2, right? Now in this case, the total compression force, how you can get the total compression force, that also we can teach you. But let me, before I work out the compression force, to work out that compression force correctly, you should work out what is the depth of this parabolic portion of stress variation, what is the depth of this rectangular stress block. These two you need to work out in terms of actual depth of neutral axis XU. So how I can relate x1 and x2? So you already know this is how the strain distribution is. I hope you people are good at similar triangles properties. In such case, if this is already x1, right, this is x2, how can you get? So you can write 0.0 from similar triangles properties for that strain block. This is strain block, you already know. You can already write 0.0035. So this value by this distance is how much? XU is equal to, this value is 0.002 divided by this distance is x1 is the depth of parabolic variation of stress block, right? So in that case I can mention how much is this one answer. This answer you will get as 4/7 times of xu, and after you get x1 is 4/7 times of xu, 4/7 times of xu. X2 you can work out as xu minus 4/7 times of xu. You will get definitely the answer of 3/7, right? So the same thing we are mentioning here. So x1 is 4/7 times of xu, which is 0.57 times of xu, and x2 is 3/7 times of x, which is 0.43 times of xu. Prakash 1985, in design we are taking FE415 strainer, sir. Yes, of course, in the design, because HYSD bars has got grips, because of which bond failure is not possible. If you take mild steel, bond failure is the only problem. So that's the reason why we are not considering mild steel rods in the design. Okay, now one more thing is, as I already mentioned, how to work out the compression force, which is the combination of, let me tell you what is C1. C1 is the compression force acting on this because of this parabolic variation of stress. C2 is the compression force acting on this block because of this rectangular portion of stress block. So here I can mention, maybe here directly I can say this may be C1 compression force acting on this one, okay, on this area. C2 is the compression force acting on this second area. What is the compression force acting on this block when this beam is under flexure? So obviously if you see, it is combination of C1 and C2. So C1 and C2. Now this is how in 3D view I can show. So you can say this is actually x2, this is actually x1, and this force here it is C1, and this force here it is C2. I need to work out what is C1 and C2, right? And you had already worked out x1 and x2. We had already done, right? Now the total compression force, if you work out, you will get this much. Let me tell you how it is. So if I want to tell that one, this you already know, this is the block and this is the neutral axis, okay? So this is the first area, this is the second area. So what is C1? C1 is the compression force acting on this first area. Over the first area, what is the average stress that is acting? What is the average stress that is acting on first area? Average stress acting on first area is 0.45 FCK, right? Is it right? Yes. Now, as you already know, compression force acting on any element, force acting on any element is average stress acting on that element multiplied by area over which that stress is acting. So what is C1? What is the average stress acting on first area? If you see, it is 0.45 FCK into, it is acting over this area, which is this width is already, you already know it is B, and this actual width is, this is already, you know, this as x2. Sorry, I should show here in a different way. So you can understand, this may be the first area here. Yes, sorry. This can be the first area, this can be the second area. In terms of block, I can show this may be of this much depth, but this is the neutral axis. So this is the first area and this is second area. So what is this first area? This is width is B and this depth is you can treat it x2. So you can write B into x2. This is C1. Coming to C2, what is the average stress acting on second area? If you see the variation of stress here, it is ranging from 0.45 to 0 stress variation, and the variation is the parabolic stress variation, right? So what is the average stress here? So for parabola, the average stress is, we can consider is 2/3 of this width, 2/3 of this 0.45 FCK. This is the average stress that is acting on this second area. Like that you can consider. This is second area. So for C2, I can write average stress acting on second area, which is 2/3 of 0.45, which is the average stress acting on second area, multiplied by what is the area, what is the second block area. It is B and its depth is x1. B into x1. So in this way you can work out C1 and C2. If you add up C1 and C2, you will definitely get this answer 0.36 FCK B into XU. But you already know what is the value of x1 here. And if you see this value of x1 in terms of XU, because the answer was given in terms of XU, na? X1 is 4 by 7 times of XU, and this x2 is 3 by 7 times of XU. As you already know, I substituted that one. If you add up the C1 and C2, which is actually the compression force. People will also ask me why you are teaching all this nonsense, because there is a question was already asked. Whenever there is a stresses change, the permissible stress has got changed. Whenever the shape of the stress block has got changed, the compression force will get completely changed. In such case, they will ask you how to find out the depth of the neutral axis. So that's the reason why we are considering. Yes. So what is the reason for CG consider for stress block instead of CG? Dear Prakash, the CG here you can't consider directly. That CG is the concept that you can mention for single type of material. This is a composite section. Because this is a composite section, and moreover as this is a composite section, in that case you are working out you need to work out with the help of the depth of neutral axis. The concept of center of gravity directly you can take here, it will be at the middle if it is in the case of single type of material. For a composite section you need to work out in this way. Okay, right. Yes, of course. So if you get this is 0.36 FCK and B into XU, and coming to tension force may be possible here. Coming to tension force, what is the tension force that is possible? Permissible tensile stress in steel. The permissible tensile stress in steel is 0.87 Fi is the permissible tensile stress in steel, multiplied by area of steel in tension, AST. Right? So this is the tension force. So you can we had worked out both tension force and compression force. Sai Krishna, good evening sir. Good evening Sai Krishna, hope you are doing good. Yes. Now one more thing also I need to mention. One more thing is here I need to work out what is this. This is C1, this is C2, where this compression force C will lie from the top level, which is nothing but Y bar. So point of application of the resultant compression force also I need to work out. So let me show that here under, if the body is under stable condition, under all the stable condition, you can say under all circumstances still failure, I can mention one thing: this compression force must and should be equal to tension force. I already mentioned the value of tension force also, which is 0.87 Fi AST, right? So when the body is under equilibrium or when the body is in stable condition, you can use this equation, this condition. Now people will also ask me, sir, you please tell me, because that is a compression force, which is a vector. I want to know its point of application of that force also, right? So in that case, yes, let me go here. Okay, let me just rub this here. How to work out this Y bar? Which is nothing but location of a force. The location of the resultant of a force can be located easily by Varignin's theorem, okay, which I taught you in engineering mechanics. So that means we are using the Varignin's theorem here to work out this depth is Y bar is 0.42 times of XU, which is very simple. How to work out this Y bar? You can already know C1 multiplied by the lever arms, the centroid distance of this C1 force from this top layer, compression from extreme compression layer, plus C2 force multiplied by the centroid distance of this C2 force from this top layer, which is taken as Y2, right? Divided by C1 plus C2. If you work out this, then definitely you will get, you already know C1, you already know C2. Just I need to teach you what is the value of Y1 in terms of XU. I need to teach you what is the value of Y2 in terms of XU. What is this Y1? If you take this from here to here, it is X2. Where is the centroid of this rectangular stress block will be here, which is nothing but Y1 is X2 by 2. So y1 is x2 by 2 I can write, which I can write as 3 by 7 times of xu by 2. In this way I can write. So you can write, coming to y2. y2 is the centroid distance of this C2 force measured from here. So how much is this one? This is already x2, and if you take any parabolic shape, it will be at a distance of 3 by 8 times of this x1. So you can write y2 as x2, which is 3 by 7 times of xu, plus coming to this is 3 by 8 times of x1 you already know, which is 4 by 7 times of xu. I hope you know how to work out the centroid for a parabola. For this parabola in this case, so if this is h, this is 3 by 8 times of h, this is 5 by 8 times of h. Like that you can understand. Gokil Pintu, sir, compression force किसका ज़्यादा ही, RCC या steel? Dear, compression force is very much good in case of steel only, because steel is a material which is equally good in compression. So steel is equally as good as it is in tension. Steel is equally good in compression for the same cross sectional area I am talking about. Okay, this is the answer for Gohil Pintu. Now coming to moment of resistance. How can you work out moment of resistance? Generally, if you take any section, what is the definition of moment of resistance? First of all, the definition of moment of resistance is resistance of cross section for externally applied moment is nothing but moment of resistance, or externally applied moment that was also coming into picture because of applied loads. So how you can work out moment of resistance? If it is based on compression force, how I can write the moment of resistance? Compression force into lever arm. You already know about compression force. How much is the compression force? 0.36 FCK B into XU. That you already know. And coming to lever arm. So coming to lever arm, if you see, the compression force is acting, total compression force is acting from the top at a distance of 0.42 times of XU. And this is the tension force where steel is existing. I hope you already know that. So now what is the lever arm between these two equal and opposite forces, because of which only the couple or moment of resistance will come into picture. Which one is, this is already the effective depth minus 0.442 times of XU, D minus 0.42 times of XU. This is the moment of resistance of any section. This is the valid rule. So you can see the same thing. Moment of resistance is C, compression force into L stands for lever arm. Now coming to moment of resistance based on tension force. So how can you work out the moment of resistance of this section based on tension force? Tension force multiplied by this is the lever arm. So what is that value of lever arm? Lever arm you can write as, which is D minus 0.42 times of XU. This is the rule only valid for limit state method. Okay, so if there is the stress block has got changed, then in such case this lever arms and the position of the resultant compression force, all this will get varied. So coming to this moment of resistance with respect to tension force, how we can write this one as, tension force is 0.87 times of Fy into AST. This is the tension force, 0.87, this is tension force. Coming to lever arm is always constant between these two, which is D minus 0.42 times of XU, right? Yes, I had done the same thing. Now coming to neutral axis. So first of all, I will tell what I want to find out in the neutral axis, what is the balanced or limiting depth of neutral axis. What this means, what is this balanced or limiting depth of neutral axis? This is the depth of the neutral axis at which both steel and concrete are failing at the same time. That means the permissible stresses in concrete and the permissible stresses in steel will reach at the same time. In such case, such type of sections are nothing but balanced sections. So if I want to find out the depth of neutral axis for balanced section, what can I do? So balanced depth of neutral axis or limiting depth of neutral axis, some people call it as critical depth of neutral axis also, right? Sir, in under reinforced section, XU goes up, na, keeps moment of resistance constant. Dear, moment of resistance is a different thing. So the moment of resistance always depends on the lever arm, definitely. Okay. So that's the reason why the moment of resistance for a section depends on the type of section, whether it is under reinforced, over reinforced, or balanced. This is the answer to Nandu here. Till now we didn't got to that extent. First of all, let us learn what is balanced or limiting depth of neutral axis. So how can I define this? So first of all, let me write this one. This is the depth of neutral axis at which both compression concrete and tension steel will fail at the same time. By that time, the depth of neutral axis is nothing but balanced depth of neutral axis, right? So in such case, people will ask us, how we will get this one. So let me teach you. This is actually the this is B, and this is the rectangular section, singly reinforced section. I hope you already know this is what is the strain block. This is the maximum strain that is allowed in concrete is this much. What is the strain in steel at the time of failure? Strain in steel at the time of failure is this much. That means if I work out the XU max using this stress block, that means you can understand the strains in concrete, the ultimate strain in concrete and ultimate strain in steel has got reached at the same time. So in such case, such type of failures are nothing but balanced type of failures. By that time, the depth of neutral axis is not just actual depth of neutral axis. The depth of neutral axis by that time is called critical depth of neutral axis or maximum depth of neutral axis. So let me work out how can I work out this XU max. If this is D, effective depth, so obviously this will be definitely D minus XU max, right? I applied. I hope you people are good at similar triangles properties. If this is theta, then this is also theta. This is strain block. If I do that one, you can directly write 0.0035 by XU max is equal to how much is the strain? 0.00. This is a strain in steel at the time of failure, at the time of yielding. So 0.002 plus 0.87 Fy by Young's modulus of steel. So which is, I call it as epsilon ST, strain in steel, permissible strain in steel, epsilon ST at the time of yielding, divided by what is this distance? D minus XU max. So from this one, I am able to work out XU max because you already know how to work out epsilon ST. Epsilon ST is 0.002 plus 0.87 Fy by Young's modulus. So from this one, what you can understand? From this one, you can understand the maximum depth of neutral axis or limiting depth of neutral axis is only dependent on the grade of steel. It is not dependent on grade of concrete. So let me write that one. So always the balanced depth of neutral axis XU max only depends on what? It only depends on grade of, because it is a function of Fy. So only depends on grade of steel and is independent of grade of concrete and is independent of grade of concrete. Can I write FCK? Yes, it is not dependent on FCK. That's what I want to mention. So this is how you can work out the limiting depth of neutral axis. And this is the thing that this is using this equation you can work out limiting depth of neutral axis. Let us suppose these are the values that was prescribed in maximum strains in concrete and maximum strain in steel at a time of failure. But if these values has got changed in our examination, in such case the value of XU max equation will also get changed. So this XU max depends on the permissible strain in concrete and permissible or limiting the strain in steel at the time of failure. Based on these two only, this value of XU max using IS 456, this is the equation. Okay, right. Now as I already mentioned, if you work out XU max for FE 41450, for example, in the previous equation, if you keep FE is, Fy is 450 for mild steel, then you will get XU max by D is 0.53 times of D. So the class will stay for next 15 minutes. Within 15 minutes, the class will be over. I am going to complete this theory part. I am just moving to problematic part. Okay, right. And XU max by D is 0.48 for FE 415 steel. People will ask us how you got this. You use this equation as you had already used it. How you used this equation? 0.0035 by XU max is equal to epsilon st by d minus d minus XU max. Use this equation, and in this equation in epsilon st, if you substitute Fi as 250, you will get the XU max by d as this ratio. If you substitute Fe 415, you will get XU max by d is this much. If you substitute Fi yield strength, all these are all yield strengths. If you substitute Fi as 500, then XU max by d is this much. How can people will ask us, till now you worked out only the limiting depth of neutral axis. Now people will also ask me like, sir, how you will work out the actual depth of neutral axis? Always actual depth of neutral axis will be worked out from the equation called compression force is equal to tension force, because even by the time the cross section or the element is under equilibrium or in static stable equilibrium, so because of which you can say you can only use this condition. So what this condition that you had used in derivation, compression force is 0.36 FCK B into XU, and coming to tension force as per IS 456 only 0.87 Fi AST, right? So from this one you can work out this XU, right? So if you work out XU, you will get this answer, right? Now let us move to problems, man. Now it's your turn. Whatever the theory that you understood, that you had seen, you just give me the answer, okay? Now, as I already mentioned, why I teach the derivation for compression force, tension force, why I had teaching the derivation for the position of compression force from the top compression fiber, that will all work here. Because if you see, this is the parabolic stress block, okay, and this is not parabolic, this is the rectangular stress block, and this 0.76 times of FCK, if you see, this is the design stress in concrete. That is, what is the design stress in concrete as per IS 456? It is 0.45 FCK, but here the value is changed. Now will you use the same things that you had? This was already given in previous gate. So if you had that background skills with you, even the stress block has got changed in terms of permissible stresses of concrete, and even the permissible strains in concrete and steel will also vary. Then in such case you can frame your own compression force correctly. Okay, without that background you can't answer this question. You are not free to use IS 456 here in this problem. Okay, now I am expecting you the answer. This is stress and this is strain. Okay, now you take, I hope you had read this one. Have you read this one? The width of the block is 250 millimeter and the depth of the block is 450 millimeter. Is reinforced with three bars of grade Fe4 and 5, each of 20 mm diameter. Concrete mix is M20 grade. Now let me tell you what is the depth of neutral axis. That is depth of neutral axis in the sense that is the actual depth of neutral axis. Whenever they mention the term called limiting depth of neutral axis, then you can use that. Then you can use the similar triangles properties for strain block. So directly you need to work out compression force is equal tension force. But how you need to work out, that is the biggest thing. Now coming to compression force, this is how the stress block is, right? So this width is not 0.45 FCK, this width is 0.67 FCK, right? And I don't know this XU. Okay, now this is the tension force. In tension force, I think if you refer, they had used 3 bars of steel, right? Now how to work out tension force? The tension force here, see compression, how to work out this compression force? Let us suppose this is the compression force in this block of this rectangular portion, and compression force C2 is coming into picture because of this straight line variation. Previously it is a parabolic variation, and one more change is the permissible stress in the block is not 0.45, it is 0.67 FCK, right? So in this case, if you work out compression force C1, so what is this value? This value you already know. How much is this? This much. If you see what is this depth here? Coming to this depth, this is 3/7 times of XU you already know, and this is 4 by 7 times of XU. Prakash, I had read your question. Wait for 15 minutes. The thing is over. You will have some more 10 more minutes. Okay, if this is the case, how to work out compression force C1? What is the average stress block? It is 0.67 FCK, right? Multiplied by, it is acting over this area. What is this area? This is B, and maybe this is 3 by 7 times of XU. So B into, let me write 3 by 7 times of XU. And coming to C2, what is the average stress for a straight line variation? So here it is 0.67, it is 0. What is the average stress that is acting on this area 2? Can you tell me? The average stress is 0.67 FCK by 2, right? So 0.67 FCK by 2 is the average stress acting on second area, and this is multiplied by second area block. What is second area here? The width is B and this depth is 4 by 7 times of XU. So it is B into 4 by 7 times of XU. If you add C1 plus C2, you will get definitely this in terms of some value, 0.478 FCK B into XU you will get. This is equal to, what is the tension force? 0.87 Fy AST. Now from this one your problem is over, right? So you previously in IS 456 you instead of 0.478 you may had used 0.36, but if you use that one the problem is gone. Coming to FCK, how much is the value of FCK? It seems like 20 is the 20 megapascal is the grade of concrete. And coming to width of the element, what is the width of the element? It seems like 250 millimeter is the width of the section. So here 250. The one and only unknown is XU is the one and only unknown. And Fy, what is the grade of steel that they are using? They are using the grade of steel Fe 415. So let me use here 415 as the answer. Coming to AST, there are 3 steel rods are there. So 3 into pi by 4 into, what is the diameter of single steel rod? What is the diameter of the steel rod that they are using? 20 millimeter is the diameter of steel rod they are using. So 20 square. So if you work out directly, the answer of XU will come. So what is the answer of XU? So coming to the answer of XU, how much? It is 142.207. Directly these type of numerical answer type questions was previously asked. So I had taken the one and same. Okay, now coming to the second question. Now here also you need to work out the depth of neutral axis, no doubt at all, no doubt. But read the problem, the same problem. The width is 250 millimeter and effective depth is 450. So this is what is effective depth. Effective depth is always measured from the extreme compression layer to the centroid of the tension steel. So and it is 450 as you people already know, and 3 bars they are mentioned. So diameter of the bars are 20 bars, okay, and 20 millimeter. So they are expecting the depth of neutral axis. There is a lot of difference between the actual depth of neutral axis and limiting depth of neutral axis. This is actually actual depth of neutral axis, right? Rajam L Kaminder, sir, will this topic be repeated on regular RCC batch of batch 2? Definitely. I am going to end in 10 more minutes, 5 more minutes only. Okay, because of discussion to solve all your questions, to answer your question, it has taken some time. Please wait for 5 minutes, the problems are over. Okay, wait only for 5 minutes. If this is the thing, they are not changing, they are asking as per IS 456. So directly you can write, always to work out depth of neutral axis you should use compression force is equal tension force. What is compression force as per IS 456 stress block? 0.46 FCK into B into XU, which is equal to 0.87 Fy AST. So just work out from this one. As you already know, FCK is 20, in the width B is 250 millimeter, and XU is the unknown which I need to find out. Fy is it is Fe 4 and 5, right? So it was given as Fe 4 and 5, right? And AST 3 rods of 20 mm dia. So 3 into cross sectional area of single rod, which is 3 into pi by 4 into 20 square. So you will get directly the answer, right? Civil Tech video is not shown. Just refresh it. I hope you will get the answer. If you work out in this way, your answer here in this blank is 189.045. Let us suppose one more question was also asked. What is the difference between neutral axis that you got from your previous problem, this problem? You need to get the difference between the neutral axis by this and that. That was not asked here. In such case also it was already happened. Coming to the third question. Third question, please. These are very, very simple problems only. Just read the problem. They are expecting limiting value of moment of resistance of the beam. They are expecting moment of resistance, limiting moment of resistance. Any moment of resistance. Generally, what I know about moment of resistance is either compression force into lever arm. Okay, I know that extent. What is the compression force? 0.36 FCK B into XU into lever arm is D minus 0.42 XU, no doubt. But here to find out XU, they had asking about limiting value of moment of resistance. That is the moment of resistance of a balanced section. What is moment of resistance of a balanced section? In the place of XU value, actual depth of neutral axis, you can take the critical depth of neutral axis. That means just replace this value of XU by XU max. Just replace this value of XU by XU max. Now you tell me, you had already gone through XU max for FE 4 and 5. How much you got? I mean here. I hope you had already seen. XU max by D. How much is the value that you got? 0.48 times of D for FE 4 and 5 steel. So to show you that one, I came backside. So let me use XU max by D. Sorry. Let me use that XU max by D here directly. So XU max here I can write as 0.48 times of D. That you need to memorize that one. To make you sure that we had already done, I had bring back that 0.48 times of D. Because if you see, we are using Fe415 steel. So in this case, if you work out, you will definitely get 0.138 FCK BD square. This is directly the formula. And the formula derivation also I had shown you. If this is the case, 0.138, what is the value of FCK that was here? FCK is 20 megapascal, and coming to the width of the section is 150 millimeter, and coming to effective depth, it is 350 millimeter square. So if you work out, the moment of resistance that we got is limiting moment of resistance. That is the moment of resistance of a balanced section. So what will be the answer that you will get? So coming to the answer, you will get this as 50.175 into 10 to the power of 6 Newton millimeter. But they asked in kilonewton meter. How you will mention that in kilonewton meter? This is the answer in Newton millimeter. So how can you answer the same thing in kilonewton meter? Divide by 10 to the power of 6. So the answer is 50.175, right? Newton millimeter. You can see this. The answer is in kilonewton meter. So divide by 10 to the power of 6 you do. So it is 50.175 is the answer that you need to type here. Okay, 50.175 or 176. Anything will work out here. Okay. Now last question for you. You see what they are expecting directly. If you see, they are expecting limiting value of area of tension steel. How to work out limiting value area of tension steel, which we can only work out from compression force is equal to tension force, but it is the limiting value of tension steel we can work out from using compression force is equal to tension force. Even from this one we can work out, or from another equation called moment of resistance of balanced section. The same problem. Okay. Here if you can see, they are using Fe4 on 5. For Fe4 on 5 grade, moment of resistance of balanced section that we already derived, 0.138 FCK BD square. So the same problem that previously that I had used, how much that we got, this is equal to moment of resistance. How I can write? Tension force or compression force into lever arm, right? So they are expecting the area of steel in tension zone. So this moment of resistance of balance section is equal to tension force into lever-arm. Because I want AST into picture. To make AST into picture, I need to use tension force into lever-arm, not compression force into lever-arm. So if this is the thing, how much is the value that you got? We got previously this value. The same problem I am using 50.175 kilonewton meter. And tension force, how I can write tension force? 0.87 Fy into area of steel required. This is the area of steel required for limiting for balance section. So AST limiting area of steel, indirectly you can write, into lever arm. You already know lever arm always is D minus 0.42 times of XU, that you had already worked out. Now this is limiting value of area of tension steel. For limiting values of area of tension steel, it is a balanced section. XU is equal to XU max. So you should write, instead of XU here, you should write XU max. What is the answer of XU max for a grade of steel of Fe415, which is 0.48 times of D? This also you had already worked out, right? So in this case, this is known to you. This is known to you. What is Fy? F is 415. AST required is the only unknown, which I don't know is the cross. D, effective depth. I think effective depth is already given. 350 millimeter is the effective depth. 0.42 into XU. It is 0.48 times of effective depth. D is, it is again 350. So just if you substitute in this way, in this only one and only one equation, only one is the unknown, which is AST limit. So what is the answer of AST limit? That's I am asking. Limiting area of steel. Now can you tell me, if you work out how much? Any answers? Nandu had given correct answer, 502.667 millimeter square. So here you can write 502.667. That's it, right? So T is equal to CS, of course. Anyway, I already mentioned you can work out in two ways. One way is using this, as I had already used this so many number of times now. So that's the reason why I came to play with the help of this equation. That is the only way. That is the only reason why I used moment of resistance is equal tension force into lever arm. Yes, of course. Yes. Sahil Yadav, sir, 72.35 in GATE civil. Any chance of PSU? Yes, I expect like there is a good chance for Sahil Yadav. Yes. Okay. Now I am going to this session is just over. Just before I make this over, I just want to mention one thing. You people came here for a trial, right? So that means we already started Vision 2020 for second batch already, and the course is for ESE and GATE civil aspirants. And this is how you will see this type of lecture that you can see for all the structural things, ranging from structural analysis, concrete structures, steel structures, building materials, construction materials and management, that will be taught by me. And in this one, the highlights are 600 plus hours in this course. This is a paid course for technical syllabus, 150 plus hours for general science. Totally together we are promising 750 plus hours of teaching. That means that depends, that can be more than that one. So we are giving every daily tests and mock quiz and even conventional papers assignments for ESE guys we are giving you. If you are seriously interested to crack the examination with good score, maybe good rank, this is the best course that I can recommend you. So and full length mock tests are also available. And these things are going to happen in the everyday evening from 7 to 9, so it depends. Okay. And some people will come and ask us, sir, is there any possibility of scholarship we will get? Yes, for few people scholarship is also available. Like if you are a GATE qualified student from 2017 to 20, you will be eligible with 50% scholarship. Okay, and if you are a student from IITs and NITs and all government college students, you are eligible with 50% scholarship. And if you are a ESE prelims qualified student, then also 50% scholarship will be given to you. So for more information, you call over this number or else the best way is you drop a mail to this email ID, or else you drop a mail to this email ID. Okay. Then you say your interest, they will call back to you. Okay. and we are giving one more extra offer on behalf of this leap year. Okay, so once in 4 years this chance will happen. You are getting extra 30% offer. This offer will valid from 27th to 29th February, only for 2 days or 3 days, 27, 28, 20. So 3 days only 3 days this offer is available. Extra 30% offer on all courses and on all green cards. Okay, that means even you can include Vision 2021 batch 2 also. To access that one, you need to use this code. Don't forget to use this code. And some more exciting offers are also there, some gifts are also there. You can avail that one. And thank you very much. Prep smart, score better, go grade up. Thank you. Give me more number of likes.